Okay, so I'm going over homework problem number 5. So we were loading in this word and asked various questions about it. So I copied this word here onto our data path, a picture of our data path. Okay. So the first question was, what is the output of the sign extend and the shift left 2? So the sign extend unit here takes the lowest 16 least significant bits. So that's here. I copied that here. So this goes into the sign extend. And so what comes out of the sign extend is just this with 16 zeros on the end. So that's the result of the sign extend. Okay. Now this value right here now comes on up to here and goes through the shift left 2. So the result of the shift left 2 is this. That's the result of the shift left 2. The next question was, what are the values of the ALU control unit's inputs for this instruction? So here's the control unit. So the first input is going to be the most significant, the lowest 6 bits of the instruction. So that would be this. Okay. And the ALU op we're going to find using the opcode. So the opcode are these bits, the most significant 6 bits. And so this value is 1 plus 2 is 3, plus 8 is 11, plus 32 is 43. So our opcode is 43. So what kind of instructions does that make it? It makes it a store word with our opcode of 43. And so a store word has ALU op values of 0, 0. So our inputs here are the first 6 bits of the instruction, or the least significant 6 bits of the instruction. So that's this value right here of 1, 2, 4, and 16 is 20. And the ALU op of 0, 0. So that's answer to part B. Part C was, what's the next instruction? So that's either going to be this shifted left value plus PC plus 4, or it's going to be PC plus 4. And that is determined by this branch value. So it's not a branch, so we're going to boldly guess that that's 0, but let's check for sure. What, for an ALU, for a store word, what is the value of branch? So here's our opcode values table. So for store word, our branch value is 0. Indeed. So the next value out of the next instruction will be PC plus 4, because that's the output from this mux would be PC plus 4. So the next question was the output of all the muxes. So we got the first one now. This one is PC plus 4. What is this one? Here's another mux right here. So this mux is chosen by regdist value. So what's regdist? Store word is don't care. So the output of that mux is don't care. Okay. This one is going to be determined by the ALU source value. Okay, so we're going to go down here. What's the value of ALU source? For our store word, it's 1. So this value is 1, so the output from this mux is going to be this bottom choice, and that's the sign extended value we calculated earlier, not the shifted one. The pre-shifted one was this divided by 4, it was 20. So the output of this mux is going to be 20. That was my dog. This mux is going to be decided by the value of mem to reg. The value of mem to reg is don't care. So that output is don't care. Okay. Cool. Now we've done A, B. We've done the muxes. We've done the piece next to the value. What's next? Did this, we did this, we did the muxes. One more. For the ALU and the two add units, what are their data input values? So what goes into the two add units and the ALU? So this ALU, we already decided that this is 20, and this is red data 1, and so that would be the value from RS, register 3, and register 3 we have is -3. So the two values going into that adder are 20 and -3. This adder, even though we don't care, this was that shifted left value, so that was the value of 20 shifted left 2, so that's 80. And then this is PC plus 4. And there should be one more. Okay, so this was just PC plus 4. So that is the problem, and I hope that clears it up a little more than what I saw from your homework.